Hi everyone, this is Sridhar. I'm currently pursuing my BE Computer Science in PSG Institute of Technology and Applied Research, which is in Coimbatore. So today we are going to see about IoT home automation. So using Blynk IoT app. First of all, thank you to Emertxe for providing this internship. So I have learned a lot of things in this internship. So we'll share it one by one in this presentation. These are all my teammates, so which is Priyanka, Yash, Grace, and myself. So thank you to all of my teammates for providing us support. So we'll move on to the presentation. So this is the table of contents. So first we are going to see what I learned in this internship. So next one is what are the requirements for the project, and then how I implemented the project, and then the conclusion. So first, learning process. Actually, it's quite interesting process because it's an online internship. So every day 7 to 9, like from Monday to Friday 7 to 9. It's an wonderful session taken by Jayalakshmi ma'am. Thank you to Jayalakshmi ma'am. And what and all I learned in this internship. So first I learned programming language. So it is very important for the IoT automation. So I learned C and C++. So why C and C++? So because it is a general purpose language, we can use it in any of the domains. So next I learned what is Internet of Things. So next one is embedded system. So we'll see that one by one in the upcoming slides. So for C and C++. So it is a general purpose language, as I said in the previously. So even though it is applied and used effectively in various specific domains. Okay. So we'll see what are the things available in the C. So first one is data types. So data type is important in every programming language. So in C we have 4 primitive data types. So those are all int, char, float and double. Okay. So float and double is used to store a decimal value, and int and character, like int is used to store the like integer value, whole numbers including negative numbers, and character is used to store the character. So next one is modifier and qualifiers. So basically modifiers are uh, used to enhance the data types, like totally 4 modifiers are there. So what are those? We'll see unsigned, signed, short and long. Okay, so these modifiers are going to used along with the data types to improve the storage facility. Okay, so next one is qualifier. We have 2 qualifiers, constant and volatile. So we'll use that in various places. So next one is condition and loops. So we have if and then if else if. So these are all the conditional constructor and then looping statements. So we have 3 loops, which is for loop, while loop and do while loop. So next one is operators. We separate operators into 3 in C language. So what are those? We'll see. Unary operators, binary operators, and then ternary operators. So unary operators, we have increment, like increment in the sense plus plus. So minus minus, decrement. So these are all unary operators. So next one, binary operators, as I said, like plus minus, addition, subtraction, multiplication, division. So next one, ternary operator, which is like almost similar to if condition. So next one is arrays and pointers. So in array we can store n number of elements of same data type, and pointers are nothing but it is used to point to some value, like some location. So in that, using this pointer we can find out what value in that location. Okay, so next one is strings. Strings is nothing but it is an array of characters terminated by null character, which means at the end of this string we always have a null character. So next one is functions. So functions is nothing but it is used to do a repeated task. Next one is storage classes. Next one is preprocessor. So preprocessor, which is used in the compilation time. Okay. Okay, so next one is C++. So it is a superset of C, and it uses the OOPS concept, so which is object oriented programming. Okay, so that's the plus point of C++. So here I have displayed main things in the C++, which is class and object. So next one is function overloading and operator overloading also there. So and then constructor and destructor. Okay, so here I have given a simple C programming. So this class, so class is nothing but it is basically a template for a object. Okay, So using this class, so my file name is my class. So using that class, I'm going to create an object called my input and my output. Okay, so basically this is what class and object. So function overloading is nothing but it's like the same function name, but we can pass various parameters to the function. And then constructor and destructor also a function, so which is special type of function. The constructor and destructor is similar, but the destructor have an negation symbol, so that's the only difference. And the constructor and destructor should be in the same name of the class. So next one is IoT. So IoT, we all know it is Internet of Things, so which is connecting all the remote objects, like all the objects to the internet. Okay, so that what IoT means. So IoT is about connecting everyday objects to the internet. So as I said, so enabling them to be controlled and monitored remotely. Okay, so for example, smart home devices such as thermos, security cameras, and lighting systems are all part of the IoT. So similarly, connected cars like automatic cars, okay, and then industrial machines and medical devices are also part of the IoT ecosystem. Okay, so next one is embedded system. So this what playing a major role here. So embedded system is it's a combination of hardware and software specifically designed to perform a dedicated function. So typically with the real-time computing constraints. Like embedded system means nothing but like we can take washing machine as an example. Okay, so washing machine is an embedded system. So it is actually combination of hardware and software which is used to do a specific task, so which is washing the clothes. Okay, so washing machine is the typical example for the embedded system. So here we have some of the examples for embedded system, including microcontroller, so digital signal processing, which is DSP, and then FPGAs, and then ASIC programming, so application specific integrated circuits. So these systems can be programmed using a variety of programming language, so including C, C++, Java, and assembly languages. So next, the project requirement. So I have did a project in this internship. We'll see what are the requirement for the project, and then like what actually this project and then what is the use of this project. Okay, first one is garden light control. So control the garden lights based on the sunlight intensity, and then brighter the light is less sunlight. Like if there is less sunlight, we need to brighter the light, and then if there is a high sunlight, we need to reduce the brightness. Okay, so next one is temperature system. Most of the house we have a heater and cooler, like in the winter places, like in the snow falling places. Okay, they have heater for the winter time, and then they have cooler for the summer time, right? So this temperature system is used to control the temperature inside the house. Okay, usually the room temperature is 28 degree, right? So here we are going to control that using the IoT device. Okay, so remotely switch on and off the heater and cooler, and turn off the heater automatically if indoor temperature is exceeds 35 degrees Celsius. Okay, so that's what the temperature system requirement. Next one is water tank control. So this is the like major issue in India, right? So they will turn on the inlet valve of the water tank, but when they will turn off, like when there is a overflow, then only they will turn off the water tank inlet. Correct. So this requirement is going to fulfill, like this project is going to fulfill that requirement also. Okay, so water tank control. So basically here also we are going to control the tank inlet and outlet remotely, and also we are going to turn off the inlet valve automatically if the tank is full. Okay, and turn on the inlet valve automatically if the tank is almost 200 liters. Like if it is going below 2000 liters, so we need to turn on the inlet valve. So next one, the hardware requirement. So what are the hardwares we have used in this project? So first one is Arduino Uno. Next one is ETHW5500, which is used to connect to the internet. So next one is PCF8574. Next one is temperature sensor. Next one is LCD display, and then LDR sensor, and then LED. So LED is nothing but to demonstrate the garden lights. So next one is software requirement. So here we need to program to that Arduino, you know, right? So we are going to use Arduino IDE. So next one is Pixim Lab. So here we are not creating any a prototype. Okay, so here we are just going to simulate all these scenarios and then we are going to solve that. So Arduino IDE, Pixim Lab, which is to simulate all this scenario. Next one is null modem emulator. So here we need to connect our remote like water tank to our Arduino. So for that we are going to use this null modem emulator. So next one is Blynk IoT app. So using this app we are going to control all these objects. So next, the project implementation. So we'll see how I implemented this project. So yeah, we'll get into this. So first requirement is garden light implementation, correct? So here the requirement is based on the sunlight we need to brighten or reduce the brightness of the LED, like garden light, correct? So first we need to sense the sunlight. Okay, first we need to find out how much sunlight is there. So for that we are going to use LDR sensor, which is light dependent resistor. Okay, using this we are going to control our LED. Okay, so it is used to sense the sunlight and send the analog signal to the microcontroller. Okay, here actually this LDR sensor will send the analog signal, but our Arduino Uno can process only digital signals. But there is a option in Arduino. We have 4 analog pins for the input. 6 analog pins for the input. Okay, so we are going to use that analog pins to read this LDR sensor input, and we are going to convert that to digital. Okay, so using this analog to digital conversion method, we'll see how this conversion is happening. ADC has 3 steps. Okay, sampling, so breaking the continuous signals into discrete signals. So analog signals are basically waveforms, right? So we need to break that into a discrete signals. So one is quantization, so discretizing the y-axis. So next one is encoding, so assigning digital value to each signal level. Okay, so here we'll see the resolution of the ADC. So number of encoding signal levels available, and then depends on the width of ADC register. In case of Arduino Uno, 10-bit register corresponding to 1024. Okay, so we need to map to this 1024. So example, microcontroller adjusts brightness of garden light with respect to analog signal sent by LDR using ADC. Okay, so here is basically the ADC block diagram. So here there is an analog input and it is going to split into 4 bits of digital output. Here we are like Arduino Uno is using a success approximation method to convert the analog value into digital. Okay, so next requirement is temperature system implementation. So here we are using this LM35 sensor. So it provides analog voltage output with which is directly proportional to the temperature of the room. So okay, so here again analog voltage is the output of this device. We need to convert that to digital again. So temperature conversion, so like this analog value we need to convert into digital, then we need to convert it into temperature value, right? So that's what here they are mentioning. So analog voltage input is divided by 0.01 to obtain the temperature of the room, which is then displayed on the CLCD, like which is LCD display. Okay, so next one is ETHW5500, which is an Ethernet shield. It is used to connect our Arduino Uno board to the internet. So like basically it is connecting our Arduino to the internet. Using our Blynk IoT app we can connect to the internet and we can communicate between Arduino Uno and then the Blynk IoT app. Heater and cooler can be remotely controlled using the Blynk mobile IoT app. So we have buttons in that like Blynk application. So we can use that button to control this heater and cooler. So data streams acting as virtual pins, so are created on Blynk dashboard templates for exchanging of data between mobile app and the microcontroller. So these are all the data streams used in this project. So one is for temperature sensor, next one is cooler pin. These are all the buttons. So cooler pin, heater, next one is volume. So this is water tank volume. So next one is inlet and outlet buttons. So these two are buttons. Okay, so next one is the water tank control implementation. So here we are going to simulate our water tank, so which is serial remote tank. So it is also included in the PIXIM lab. So serial remote tank is a simulator used here to control inlet valve or outlet valve. So we need to send a byte 0x00 for the inlet and 0x01 followed by another byte which is 0x01 to enable and 0x00 to disable. So actually we need to send two signals. One is to mention inlet valve or outlet valve. So next one is to enable it or disable it. So here we need to use this serial.write function to write this value into the serial tank. Okay, before that I am telling serial, right? So here we need to connect our Arduino and then our serial remote tank serially, so using the null emulator. Okay, yeah, so here is the null emulator. So null emulator is used to set up serial communication between our PIXIM lab and the serial tank. Okay, so usually we will connect the COM1 and COM2 serially, like COM1 is in PIXIM lab, COM2 is in our serial remote tank. Okay, 0x30 byte is sent to request data from volume sensor. So next one is serial read. This is going to read the value like volume from the serial tank. So usually it will read 4 bits, so which is high and low, like which is MSB 4 bits and LSB 4 bits. We need to read it twice and then we need to merge it. Okay, so next one is, this is our serial remote tank simulator. So here we need to connect it with the COM2. So yeah, so we are almost came to the conclusion. So here I have included all the simulator, all the components we have used in this project. So this is the Blynk IoT app. So here we have inlet and outlet and then the volume gauge, like here it will indicate the volume level of the tank. So next, this is the Arduino IDE which we used to program to this Arduino board. So this is the PIXIM lab. Here we have simulated the Arduino Uno board. So next, this is our CLCD, which is LCD display. So next one is, this is our LED which is to demonstrate the garden light. So this is our serial tank and then this is our heater and cooler. So this is our Ethernet shield. Thank you. We'll get into our project demo video. So here is our simulation for the project. So here you can see the LCD display and then LEDs, so which is simulating the garden lights. So here is our Ethernet shield which will connect our Arduino to the internet, and here is our heater and cooler component, and this is the LDR sensor. So this is to simulate the sunlight. Okay, so here is the first demo to control the garden lights. Okay, so if the sunlight is increases, the garden light should decrease, and if the sunlight is decreases, the garden light should glow brighter, correct? So here the sunlight is inversely proportional to the LDR. If the sunlight is high, the LDR resistance will low. If the sunlight is low, the LDR resistance is high. Okay, so here that's what we are simulating. So here you can see, as the LDR resistance increases, the garden light also increases. So here it is nothing but we are telling that sunlight is low, increase the brightness of the light. Okay, so this is the garden light requirement. So yeah, so brighten and then reduce the brightness of the garden light. Okay, so that is one part of our project. So next one is the heater and cooler. So we need to control it remotely, and I have displayed the temperature here in the LCD also. So here the current temperature is 27.34 degrees Celsius, and the cooler is off now. Okay, so we'll see if my heater is turned on, what is happening. So here I turned on my heater and the LCD is displaying that heater is turned on. So once you can see the temperature reaches the 35 degrees Celsius, the heater is turned off. Okay, so here in the mobile display also you can see the temperature is more than 35 degrees Celsius, turning off the heater. So now I am going to turn on the cooler. See, I turned on the cooler So the cooler is now turned on, and the temperature is reduced to the room temperature, which is 27 or 28 almost. Okay, so that's what our heater and cooler um requirement. So next one is our remote serial tank. So in our mobile application we have created another tab for this serial tank. So now I'm going to turn on my inlet valve. So my inlet valve is turned on now. See, so once it reaches the 3000 liters, it will automatically turn off. So now my inlet is turned off. Now I'm going to turn on my outlet. If my tank is full, I need to turn off the inlet. If my tank is less than 2000, I need to turn on the inlet. So see, now my tank now reached 2000. My inlet valve will automatically turned on. So that requirement also displayed here. So now I'm going to turn off the inlet. See, all the operations done in my mobile application is displayed in this uh, CLCD display. See, now my volume is 2000 now, so I can turn off my inlet valve. So that's it, the project implementation. So thank you for the opportunity given by Emertxe. So thank you all. Signing off, Sridhar.